My name's Sarah Earle and I lead the Teacher Assessment in Primary Science TAPS project. In this video, we will provide examples of the fruitful links that can be made between science and design technology. An inquiry cycle in science can be very similar to a design and make cycle in DT. There are common processes within the planning, doing and reviewing, while science investigations aim to collect data to find out the answer to a question, like how can we use friction to slow the marble down? DT aims to make a successful product, applying this scientific understanding to make the marble run. When planning for such challenges, it's worth considering which element of science in DT will be the focus for teacher observation or pupil recording. For example, sometimes a design context can provide you with lots of opportunities to find out about children's conceptual understanding. For example, when making models with electrical circuits like these Scribblebots, children can be asked to explain how they work to hear about their scientific ideas. This water filter challenge from Practical Action's Ditch the Dirt activity provides the opportunity for pupils to explain their design process of trial and error as they try different materials and layering to filter the water. They can also be asked to explain their choice of materials, to consider their properties and the way they catch small or large particles. When testing gliders or paper planes, the focus could be on planning, to recognise and control variables from a science perspective, and to consider the use of different materials from a design perspective.
You want it to be very light because otherwise the wind won't be able to pick it up and then it'll just fall down onto the floor, but it's got to fly straight.
We decided to make it out of the template and the straws for basically ailerons and paper clips, both to keep it together, and they add a little bit of weight so it doesn't do loops and things. We tried it and it worked pretty well. It almost made the distance, except it went a long way to the right. It was turning right at the end, so we decided maybe we could bend that to make it turn left.
Here's some other children who were challenged to make a steady hand game.
So we've basically made a circuit, which is kind of a beat the buzzer. So you have like these games at carnivals and things where you have a metal kind of thing to hold on to, and then there's a wire, and you have to try and carefully with steady hands go around and make sure that you don't touch the wire, or otherwise it will make a very loud buzz noise. So we've tried to make that today, and we actually made it work, surprisingly.
So it's just basically one giant circuit. So the batteries power to the wire, which makes the wire sensitive. So this is I think it's giving off an electrical charge. So this is like contained with electricity, but not so much. And then this is connected to the buzzer. And then the buzzer is connected to this. So when this touches it, this is obviously giving off the electrical shock. And so they're both metal, so they're both sensitive, and they both have electric. So when this touches, it gives the electrical shock, and because it's connected to the buzzer then activates.
You would connect it to the red one because you need to, I don't know how to explain it, but you need to make it so it connects, and then to connect to the green one, because if you look here, the green one connects to the other red one that's connected to the batteries. Then if you would have a black one, it's connected to the white and yellow one.
Well, we've attached the battery pack and the buzzer together, but we've also put a switch in the middle, but then we had to attach one of the wires on the switch to this wire and to the one at the end, so it would know when it had hit the wire. So but then when they don't make contact, it doesn't make a sound because they're not connecting. Yeah, because this is working like another switch because it joins everything together.
Design technology challenges can provide fruitful contexts for developing science skills and applying conceptual understanding. It helps to consider which areas of learning will be the focus for the lesson. The TAPS project has produced a range of plans to support this focused approach, which are all available on the TAPS website.